Good evening to one and all. Today we will see the essential parameters for repair material. So if a repair material is there, what are all the parameters or property it should have so that it can be called as a repair material. The first main important thing is its low shrinkage. So the major drawback in a cement based material is that it will try to shrink. Okay, there are many shrinkages are there. Okay, as we already discussed about the type of shrinkage, namely the plastic shrinkage, thermal shrinkage, autogeneous shrinkage is there, drying shrinkage is there. So this type of shrinkages will happen if use a cement based material. So we have to choose a material in such a way that it should not shrink. And second one is that it should have requested setting and hardening properties. So based on the requirement or the application, the material should be of quick setting or delayed setting. Okay, so the setting properties can be altered, okay, in such a way that it suit the field condition. For example, if you're going to repair an concrete road, for the traffic should be allowed, okay, within less time. So nowadays repair materials are available that within half an hour, okay, the required strength can be attained and it can be open for traffic. So like that quick setting we have to prefer. And you consider in case of the cold joints where a continuous, for example, a drainage canal is made. So in that case what we have to do means, so within a single day we can't complete the entire 5 kilometers of the road. So each and every day we may have some planning, and next day we have to start the work. Suppose if we use a normal cement based concrete means it will try to set, and a old concrete will be formed, and the next day if we just continue with that work, the new concrete, okay, if we placed on the old concrete, yeah, weaker zone will be created at its junction. So bonding won't happen and it will act as an okay, failure medium. So in order to avoid that, the old concrete should not set until the new concrete is placed. So we have to extend its setting time. So we have to slow down the reaction. So for that some chemicals are there and some repair materials also is there, so to increase its time of setting. Okay, so next one is workability. So whatever the repair material I'm choosing should be workable also. So in strength point of view it is very good, but it is a very solid material, okay, we can't work on it, then that material, okay, should not be used as an repair, for repair purpose. Okay, so it should also be workable. And also the bond, this is very important. See, whatever repair work we are doing, it is not a new work, already existing concrete or the existing building only we are going to do the repair work. So in that case, okay, it should have a proper bond. So if the bond is not there, then ultimately it will try to fall down. So the patching work what we are doing, or for spalling, okay, whatever the repair work should not come out from the surface. If you use a normal cement concrete, what will happen, or cement mortar, due to the shrinkage property, okay, it will try to uh, form the cracks along that okay, bond between that old and the newly applied concrete, and it will try to fall down. So it should have a strong bond with the substrata. That means substrata means old concrete, and it should have compatible, okay, coefficient of thermal expansion. So whatever the expansion happening for concrete, similarly it should also expand. If there's a difference in expansion, what will happen, then that also will result to the stresses concentration and cracks will be formed. And it should have compatible mechanical property and strength. See, mostly you might have seen in the roads, concrete roads. So if a new road is laid by a concrete means it will be very pleasantly looking. Suppose if for okay, the placing of the cables they dig, okay, they break the concrete, okay, and they alter the concrete nature, okay, and then they will place the cable, and once again they will try to cover with some new concrete. So that new concrete may not be having the same property of the old concrete. Sometimes the new concrete will have more strength than compared to the old concrete. Okay, so if there's a difference in that mechanical property means ultimately, okay, the joints or it will exhibit a different properties. Okay, so those things should be avoided. So the concrete what we have made, okay, so should be matching with the old existing pavement concrete properties. That also we should be ensured. So nowhere, okay, that also we can take it for research. The bond between the, okay, old concrete and new concrete, okay, how to, okay, make it compactable with the old roads. Okay, we can make a study, because nowadays lot of problems are created. So if they made a concrete road means, okay, for placing these cables or for some other repair work, if you just disturb the structure or orientation of the old, okay, concrete road means, then entirely that stretch of road will be disturbed. Okay, you'll get lot of undulations, potholes, okay, like wear and tear between the old and new concrete. So thereby the people who are riding on them won't be feel comfortable. Okay, and next one is the relative movement if expected. Suppose if any movements are required, like elastomers we are using means, that also the repair material should be relative. It should not be like a mastic, a stiff material, solid material. It should also try to move along with the existing material, and it should have minimum or no curing. So as I told, okay, repair work are done in case of some emergency maintenance, or in case of the repair of the, okay, concrete road means, it should be immediately allowed for the traffic. So we can't wait for some 7 days or 10 days to do the curing work. Okay, so in that case I think most of the roads, whatever repair are doing, they won't do the curing at all. Once they will okay, finish it, and then they will allow it for some 8 to 6 hours of okay, open to setting, and then they will allow for the traffic. Nowhere I seen some 7 days or 6 days of curing is done. That itself is one of the bigger loss for retaining the strength, and also failure of this repair material. And next one, regarding the alkalinity, you already know is concrete is an alkaline material. Okay, its pH will be around 12 to 14. So whatever the repair material I should choose, it should be of alkaline nature. If you use acidic material, what will happen? And automatically corrosion will happen. It will lower the pH, it will disturb the passivity layer surrounding the reinforcement, and finally it will result in corrosion only. Okay, so the pH also should be ensured to be in alkaline medium, and also low air and water permeability. The repair material what I choose or prefer should be of no or less permeability. So you already know concrete is a porous material, so we should not choose a material which is repair material which is also porous. So it should be solid enough that it should not allow water and air to enter. So that is the purpose of choosing a repair material. Once it is impermeable, then no air and water will enter, so thereby corrosion won't happen, and its passivity medium of the reinforcement will be older. So it can ensure a longer life. And aesthetic, so nowadays, okay, some of the repair material what they are choosing will have some fibers in that. So the fiber length, and also the quantity of percentage of fiber used plays a major role. Okay, if it exceed than 2 percentage, and if the fiber length is longer means, then it will form the balling effect. And also the surface smoothness also we can't get, finishing won't be good, it will be protruded outside. Okay, aesthetically it won't be look. So if you're using this type of fiber, but fiber is a stronger material to take the tensile load. Even though the property is there, when it reaches the customer point, to the customer end, it should be having that good finish, smoother finish. Okay, and aesthetically it should be good. And next one, cost. This one is an important parameter. So whatever repair material, okay, I am making, okay, it should not be costly. Okay, too much cost the people won't afford. Instead of that, they will demolish the building. So the repair material should be such a way that, okay, the cost should be somewhat less. So it should not be equal to the cement I am telling. Okay, but somewhat, okay, some 5 or 10 percentage it can be more. Okay, not one time or two time, double the time the cost should not be there. So nowadays an excellent material called sterile butadiene rubber, SBR. Okay, many industries, cement related companies are manufacturing themselves, and standard chemical companies also producing this SBR. So which is a major all rounder. Okay, it can be used for all the repair works. Okay, so like waterproofing, like bonding agent, and many things it can be preferred, but it has some lower nature, or okay, or lower capability to withstand the UV rays, sunlight. Okay, that is the only issue which I came to know. Other than that, it is an excellent material. Okay, so the cost what we are okay planning, okay, will be affordable with this SBR. Okay, so that is an okay, excellent material. Next one regarding durability and bio non degradability. So durability is also very important. Whatever repair material I should choose, it should have a minimum guarantee that it should come for 10 years or 5 years. Within 1 year the repair material is been uh, this life of the repair material is been reduced, or okay, it cannot be exhibiting the property for what it has been provided. Suppose if you are making an waterproofing coating for the ceiling, okay, it is coming only for 1 year, means then okay, the purpose of using that material is not satisfied, durability is very low, so those material we should not choose. At least it should come for some 5 or 10 years, okay, and it should not be bio not gradable, okay, not degradable, so that is also very important. So sometimes fiber reinforced concrete will make use of some natural fibers, so even though it has a good tensile property, but what will happen, okay, with the period of time it will try to degrade, so that is not preferred. Okay, so last one is should not be hazardous, okay, non hazardous material we should choose, and it should not be non polluting. See, many repair materials are there which are very toxic. Even I told about SBR, we should wear a proper protective gloves, and then only we should use those material. Okay, so most of the materials are hazardous, but it should be within the limits, okay, for the human health, without damaging the okay health of the human being. So these are all the some of the essential parameters, okay, which we have to keep it in mind to choose the repair material. Thank you.